Okay, number 38. Estimating how long it took King Kong to fall down from the Empire State Building. So I drew a little diagram here, as you should, to help visualize what's going on. So if he is jumping down, I labeled my ground 380 meters above. He is falling downward, so that would actually be a displacement of negative 380 meters because he is moving down. Down direction is negative. That also matches our acceleration, which is negative, right? So anytime something is in free fall, this is always its acceleration. And it's at this, when he first jumps down, his velocity will be 0 meters per second. So this is what we know. And for part A, it wants to know about the time. So we know his starting velocity, we know the distance, the displacement, and we know the acceleration. We want to find time. So the one that we want is the one that doesn't have final velocity. That is this formula right here. So we will start with that. D equals VIT plus 1/2 AT squared. Okay, the first term is 0 because the speed is 0, so we can just cancel out that first term, and we're left with D equals 1/2 AT squared. Now if we solve for t first, see, I'm going to get t squared alone first by like that, and then I'm going to take a square root, and we're going to get t equals the square root of 2d over a. And this is a formula, you'll see this online when you're looking up free fall problems, but you won't have this formula on your test, but you will have this one, and you will have these ones. And these formulas you can use for anything to drive any type of free fall equation. Okay, so square root of 2, displacement was negative 380. Acceleration, I'm just going to do easy math and call it negative 10. So 2 times 380 divided by 10, we get the square root of 76. And the square root of 76 is about 8.7 seconds. So poor King Kong was falling for quite some time. He was probably quite scared. Imagine if you were falling and contemplating your fall for that long. Quite scary. Okay, his velocity just before landing. So now for part B, we want to know this final velocity. Whoops. And the final velocity, again, common thing to mistake is some people are going to say, oh, when he hits the ground, he's going 0. Once he hits the ground, he is not in free fall anymore. So we are actually looking for what's called the impact velocity, which is the speed just before he hits the ground. Okay, so for this one, we could use multiple equations because now we have the time. I'll go ahead and use the original values we had. So I'll use v0, the distance, v final, and acceleration. So the only one I don't have is time. So I'm going to go ahead and use this one right here. So v final squared equals v initial squared plus 2ad. So the final velocity is just going to be the square root of that. So we get the square root of, it's starting at 0. So it's just the square root of 2ad. And that's 2 times negative 10 times negative 380. And 2 times 10 times 380 gives us the square root of 7,600, which gives us square root 87, we'll call that 87 meters per second. So he was moving at 87 meters per second, quite fast. I think in the movie he survives, but I don't know how something would survive at that speed. That's almost a football field in a second. That is quite fast. But I guess that's why it's a movie.